Hello, my name is Peter Kim, and this is my lab for oscillation for Physics 2211. Now, a quick overview of what we'll be going over today in this lab is the purpose behind the lab, now basic physics concepts that one must know before coming to the lab themselves, procedures, the data analysis, conclusions, as well as lab questions. Now, the main lab objective was to understand the motion of a spring mass system with the mass oscillating in an arc to determine if the model follows the energy principle. Now, some basic lab information before we start. Our tools that were used were Tracker, Google Sheets, as well as GlowScript. The system was a spring, earth, and block, with the surroundings being just nothing in general at this time. Now, physics concept one must know before doing the lab is Newton's second law, F equals ma, or the acceleration of an object, is equal to the net force divided by the mass of an object. Now, in the energy principle, the change in energy of a system is the sum of work done by surroundings and thermal energy exchanged with the surrounding. And we continue on. In this lab, there is no external work being done on the system, nor thermal energy being exchanged, which makes Q as well as W equal 0. As we can see in this formula, delta E is equal to Q plus W, as well as the velocity update and the position update formula. The procedure following the lab is step 1, to have a video or record a video of an oscillating spring mass system. 2, to import the video onto a tracker application and set up frame by frame to see the observed positions of the mass. Step 3, using X position and time for the tracker, import to Google Sheets and export it as a CSV file so we can import it to tracker. They use a GlowScript to create a computational model of the mass's predicted position with the use of starter code using initial position and time from tracker, as well as a CSV file from earlier. And the goal is to compare the models and create a final conclusion. Now, observe data, tracker video. So this was my video from before where the original position, as well as every frame by frame setup. As you can see on the right is a graph, a graph that shows the X in time and a time by y-axis, each showing a sine wave. And to observe a spring mass object oscillate, the total time it took for the video was 9.117 seconds, as well as the initial position being 0.101 on the X and negative 0.751 on the Y of meters per second. Tracker created both X-axis and versus time graph and Y-axis versus time graphs. Now the GlowScript code. Our G was set to 9.8, as well as the spring constant 0.683 given by the video, as well as the rax length of the spring, which was also 0.123 or given by the video. L we were able to find with ball dot position minus the spring dot position, as well as L hat being found by using the L from before and dividing it by the magnitude of L in order to get the unit vector. Here we are able to find the next 4 lines by using the formulas that we know of the kinetic energy, 1/2 times mass times the velocity squared, as well as mgh, or in this case ball mass times gravity times the ball position on the y-axis, as well as the spring constant, spring formula using 1/2 times k times s squared, and the total energy being adding up all the other kinetic and potential and spring potential energies. Here on our right, we have all our code, as well as update the force of gravity, as well as the force of spring. As we see here, we see the velocity update formula, position update formula. Now, model observation. Here we have the actual projection of the model itself, as well as all 3 graphs were showing the X position versus time, as well as X position versus time on the right. On top, we see a total graph showing every single component of the delta E equals 0. Now, lab questions. Is the energy principle satisfied? Yes, it is satisfied as no external force is being acted on the system. The change in energy should be 0, and which we could see on the graph where the orange line shows that delta E, or total energy, is equal to 0 as everything else evens out. As there's no extra force or external force being acted on the system, the change in energy is still 0. Now, the average oscillation period for X position was 1.709 seconds, whilst the average oscillation period for the Y position was 1.519 seconds. Now, the difference between the 2 oscillation periods may be due to forces that were not counted within the lab, such as drag force or rounding errors that could have occurred while calculating for each oscillation period. Thank you.